Hi everyone, my name is Arjun Konijeti and my mentor's name is Kristen Sorrell. I'm presenting from San Diego, California, and I chose to research black holes because I find them to be one of the most strange concepts in our entire universe, and I wanted to learn more about them. The image in the background that you see is the first image ever taken of a black hole called Sagittarius A, which is the black hole in the center of our galaxy. Um, so there are multiple different types of black holes, with the two primary ones being stellar mass and supermassive. Stellar mass black holes are the ordinary black holes that one would think about and are formed when a star collapses at the end of its life. Supermassive black holes, on the other hand, are the black holes that are found at the center of every galaxy. It's theorized that they are formed from vast clouds of hydrogen gas that eventually collapse into a black hole, as you can see in this image, where there's a bunch of hydrogen gas, and then it can branch off into two different possibilities. First, it will form stars, which will eventually grow, and then eventually they'll collapse into a black hole. Or it'll go directly to a black hole. So it starts with a bunch of gas collapsing, and then the large seed grows really quickly, and that forms a supermassive black hole. But it's not proven. Next is the anatomy of black holes. So when a black hole is formed, it has an accretion disk, which is the bright ring surrounding the black hole, made of the matter and light that was caught. And then Doppler beaming is when the light on one side of the black hole is brighter than the other because on one side the matter is moving toward us, whereas on the other side it's moving away. The photon ring is the last bit of light that managed to escape the black hole and make its way to us. So it was about to fall into the event horizon, except it just barely managed to get out. And what the event horizon is basically the very center of the black hole, where nothing can escape, and nobody knows what's in there. So when we take images of black hole, we see them like this, with sort of a hat, and then this bottom part instead of a sphere because of the path of light as it moves around the black hole. So uh, when you observe black holes, there are a lot of different ways to do it. One way is through the accretion disk, another is through particle jets, and then there's also ripples in space-time and unusual movement of stars. So because the accretion disk is really bright, we can sometimes use it to observe black holes when you have a really high power telescope because black holes are so far away from Earth. And then particle jets are when the matter in the accretion disk of a black hole is shot out so fast that it produces X-rays. And if they shoot out close to Earth, we can use them to trace the location of a black hole. And X-ray is the second most powerful type of radiation next to gamma rays. And ripples in space-time happen when two or more black holes collide with one another. And with really advanced technology, we can detect this and use it to find the location of black holes. Um, you can see in the image in the top right, it's pretty easy for three black holes to cause a large enough impact for us to observe it from Earth. So lastly, we can use the unusual movement of stars to conclude that there's a larger body that's making that unusual pathway. And that would most likely be a black hole because it has such intense gravity and that's causing the movement. And using math and physics, we can calculate the exact location of the black hole. So spaghettification is pretty much exactly what it sounds like. It's matter being turned into spaghetti or spaghetti-like shape. So the fabric of space-time refers to the imaginary fabric that can be manipulated with gravity as seen in this bottom left image. A black hole has so much gravity that it forms a singularity. Um, and that's a point in space that's infinitely dense and infinitely small. But because the singularity has such intense gravity, the objects that's falling into the black hole is stretched with such extreme force that it turns into a spaghetti-like shape. And it stretches more and more as it gets closer to the event horizon, as you can see in this image where a person is slowly falling in and then he stretches out. as he falls into the black hole. This image also used the Schwarzschild radius, or the radius of the event horizon, along with lots of other complex physics, and to mathematically show how a human is, or any object is stretched as it reaches the event horizon of a black hole. So, in conclusion, black holes are one of the most complex celestial objects found in our universe. Their properties continue to astound humans. However, we are very close to finding an explanation to how and why they exist. Thank you for listening.